into three categories of creational design patterns, structural design patterns, and behavioral design patterns. So basically each class would be dedicated to one of them. That leaves us, what I will be assigning to you as a reading assignment is the UML, which is the modeling language, unified modeling language. The presentation slides are up on Canvas. So what the time you are not doing implementations on the project, please go through those slides, and then we will try to figure out one of the days, either during those 3 lectures or a little bit an optional extra class where I could answer your questions on UL. Okay? So that is pretty much the plan from going here on. The final exam week is when we will schedule your final demos. I have to look up what the final exam slot for this class is, and then we'll discuss if that is convenient or do we want to move it anywhere else. So we'll figure that out. And that will be the time when you will take the remaining 20 points of your test 2. Okay? On test 1, I sent out an email yesterday giving you the statistics and the topics that will be covered on the makeup test. 6 of you are exempt from taking the makeup test. I had emailed those students separately also. If there is any confusion, please email me and let me know. It's basically, if you scored above 65, you are exempt from taking the makeup test. I wanted to say above 70, but we have one student with a 69.5, so that is why I said 65. But basically, 70 and above, kind of, including that 69.5. There are 6 of you who don't need to take the makeup test, and everybody else needs to take the makeup test. Okay, it's highly recommended. I mean, you don't have to take any test. I can't require you to take any test, but highly recommended in case we are planning to pass the course, which I'm sure everybody is. I don't look forward to putting any F against any name. That's my. The only reason I like to put F is if somebody stopped attending, but that's the only reason. Otherwise, it makes no sense in putting an F. Okay, so you have the makeup test. On the really speaking, I did give you a more detailed thing on the email, but only thing that is not on the makeup test are like your variables. Functions, we did I wasn't so happy with the parameter passing mechanisms, with the prototype, the signature, the overloading, so all that is candidate for repetition. And in classes, even though per se in chapter 3, I can say classes are okay, but classes are going to be there anyway with inheritance, and I mean it's the basic structure. But the most, you were okay with the private and the public, but operator overloading is something that was not so okay. So, so that is why I gave you those breakup and exactly what was weak, etc. But pretty much, I mean, when I look at it, STL templates were there. It's pretty much a repetition. But again, focus on those areas more is what I would suggest. When variables is not a big deal anyway, whether you review it or don't review it. And again, as you are reviewing, if you feel there is something that you are not sure if you should review or not, or it would save you time if you didn't have to review it, just shoot me an email and let me know, rather than worrying and spending more time on it. So say, I wasn't sure if this is on the makeup exam or not, should I study this or not? It's very easy to answer. I will check it and let you know. Okay? So please feel free to email me as many times as you need to help you out in any way to prepare for the exam. Okay? Again, I think we talked about it earlier. I think very important, if you can, try to prepare, keep 2 different time, manage your time wisely towards your test 2 and the makeup. You do not want to spend so much time for makeup exam that you perform poorly on test 2. Okay? So make sure you say, okay, I'm going to use 2 days to prepare for makeup and 10 days for test 2 or whichever way, I mean whatever works for, but don't mess up one at the cost of the other. There will be no makeup on test 2, even if our class average is super low. That I'm telling you in advance. Okay? So make sure you appropriate your time proportionally accordingly. Okay? Let's then start off with what we have to look at today. Yes?
What would be the timings for these tests?
It class time. 2 hours, within 2 hours everything. Probably 1.5 and half, something like that. But we go 3 to 4 or at the most, let me see. I don't think more than 2 hours really makes sense. At the most 2.5.
No, I was asking was if you're planning to take the makeup test first and then the test.
No, I'll give it to you together. So it will not be 2 different administrations.
Okay.
I'll give it together and then whatever time you need to finish them both. So it will start the same time for all of us, whether we are taking makeup or not. People who are not taking makeup will leave early. Because otherwise it will be too difficult. At 2 hours I say the test is, then whoever was done has to stay back for another half an hour. So I'll just give you maybe 2 separate bunches, but I'll give it together. Okay?
What is the date for the exam?
Wednesday, November 30th. Yeah, November 30th. Almost December. Before we started the class, one of you had come up and was asking if I need to, what do I do? So in this particular case, we were looking at the dice face hierarchy, and in this particular hierarchy, the color was added as an attribute in the second level, the green dice face class and the red dice face class. And the label had been added at the third level, okay? So, and then you need this accessor method called getColor and an accessor method called getLabel. So the question was where to put it. What is the right place to put these methods? Should it be put in the base class? Should it be put at the second level or the third level? Can be placed You could put it anywhere, but is there a better way to do it? Now, if you think of that I have to use the base class pointer is going to be pointing to an object and calling the methods. I expect the get label method to be implemented by all the subclasses, and therefore I think it should be pure virtual in the base class. That's one way to think of it. The argument against it is, when there is no attribute called label in the base class, why should there be an accessor method called getLabel in the base class? Right? So the general rule of thumb is the accessor methods should be introduced at the level where the attribute is introduced. Okay? So if for whatever reason the label has been introduced at the third level of at the base level of the hierarchy, I shouldn't use the term base, at the third level of at the bottom level of the hierarchy, then the getLabel method should also be introduced there. Now, if I introduce the getLabel at the bottom level of the hierarchy, can I use the base class pointer to call that method? Okay, I don't hear any answers because probably you haven't tried it yet. But when you do try it, you will say, oh, now I have hit a problem that the base class pointer is pointing to my objects, and the only methods that I can really call are the methods that were introduced at the base class level. They might have been virtual methods that have been overridden in the child classes, but they should have been introduced virtual, non-virtual, pure virtual, in whichever way, but the function itself should have been introduced in the base class. So that brings us to a peculiar problem. We say when we create child classes, the idea is to specialize the class. It should add attributes and methods. How do I call these methods that I add at the child class level? How do I call? So here is the question. How do I call a method that is introduced, not overridden, okay, first time introduced in the child class through a base class pointer? If you try to do it just like that, it will give you an error, and will give you a simplified example and show you the problem and the solution. So that's the question we are tackling today through runtime type, and the solution is through runtime type identification. So here you are looking at a code where we have the base class as class X. It is a standalone class. It doesn't use any inheritance by itself. It has introduced two attributes, A and B. There are accessor methods to set A and set B, and get A and get B. This is a dummy method. Okay. In case you have a base class, if you have to use runtime type identification, there has to be a virtual method in the base class. Okay, that is how runtime type identification worked. I should check it in the newer IDEs, but in the older IDEs you needed to put through virtual. So this function f has no functionality of its own except that to make RTTI possible. Okay? Maybe in the newer IDEs you don't require it anymore. I should check that out. But that's the only purpose it is there. Now we have a class Y that declares X to be the parent, is using public inheritance, and all it does is introduce a new attribute C, like in the example I was saying, if you introduced color at the second level or label in the third level, whatever. So if you introduce the label wherever, the accessor method should sit in that class. So you will see set C and get C are new methods in the child classes. We are not overriding them, right? We are introducing them at that level. So we have introduced a new attribute and new accessor methods. Now in the class, if I declare an object of type Y and a base class pointer, and make the base class pointer point to the Y class object, I could have also written x pointer xp, xp is equal to new y object. That's what probably you are doing for your die spaces. So that is immaterial. Okay, the point is that a base class pointer is pointing to a child class object. Now does y1 have the method setC and getC? When I declared this object y1, can I say y1 dot setC, y1 dot getC? Yes. Can I say y1 dot set A, y1 dot set B? Yes. Because public inheritance, so the accessor is still public. Okay. Again, same thing. Whatever we learned stays as it is. Whatever we are learning is on top of the knowledge that we have gained. So we are not changing anything. Okay. So yes, y1 can call any of those 6 methods using y1. Okay, but if I said xp get c, okay, so look at just this part of the code, and if I had used, so don't worry about all the code that has come since, after xp is equal to address of y1, if I said xp point the arrow get c, that would have given an error. It would have said I cannot find this method because it's not an overridden method, right? So it will not go to the virtual table, right? And it is not in the parent class. So it is not going to check that xp should go and check the object. It is not going to take that extra step. Okay? So how do I make the call to setC happen? Okay? One solution, which was the only solution you knew till now, is take the setC into the base class and make it virtual. Okay? And if I didn't know what to do with it there, I make it a pure virtual because C has not been introduced, but I need to call it, so I take the setC up there and make it pure virtual. I see this solution all the time in your projects. It is a solution, it is not a good solution. Why is it not good? Yes.
Because a lot of entities, functions might not be appropriate to some classes which are inheriting the base class.
Absolutely. You are making the base class unnecessarily fat. Right? Yeah. The other problem is, what if you are not the one who are designing the base class? You were designing the base class, I was designing the child classes. You designed it 20 years back. I am inheriting from it now. You did such a great job that it is part of the standard libraries. Can I go and start changing the classes in the standard libraries? No. In general, I should not be changing any code that anybody else has written. Okay, so that would have left me with only one solution, that I copy all your code, make a class, a new class of my own that has exactly your code, throw in that virtual function, and then write my class. The whole concept of code reuse went puff in the air, right? Copy and paste and start using again. So, therefore, it is not a good solution, right? So that is one point. And then the question becomes, if that is not a good solution, then how do I make it work? Because the point is, I want to call this method. Okay? So now in runtime type identification, as it is self-explanatory, it is saying, how do I find the type of an object at runtime? Okay? So now the path I am going to take is, I am going to check what is the type of the object pointed to by this pointer. Okay? So there is a way to do that. That is what we are learning. It is something new. We haven't talked about it before. And then use that information to help us. Okay? So in where it says the next two lines are only to show output of the type ID operator, those are not needed every time you are using it, but if you are curious how the type ID works, that is why it is there. So there are two sets of solutions. You can use so there are two techniques when runtime type identification is concerned. One technique is known as using the type ID operator, and then in the second page we will see we can also use what is known as dynamic casting. So it is up to you. So you have two choices. Both will help you do the same thing. So if you here you are using, so you to use the type ID operator, IOStream is for input output, type info is the header file you have to include, pound include type info needed for using type ID operator. And then the string, I will tell you why you need the string class. Okay, so here those two are needed for the type ID operator. So here, when I say type ID star XP, okay, what is the difference between XP and star XP? What's XP? X pointer, right? X base class pointer. So what is the type of XP? X pointer. What is the type of star XP?
X.
Y. Star XP means you are dereferencing the pointer XP. Where is XP pointing to? Y object. Okay, so this is the type of the object that XP is pointing to. It could have been X. If here it said XP is equal to new X, if it were pointing to an X object, then it could have. So it can be X, it can be Y. But right now that we know from the code, it is Y. Okay, so here we are checking the type of the pointer itself. Here we are checking the type of the object that this pointer is pointing to. This call returns the type, and when we call the method name, okay, so it returns an object. You don't have to worry, I'm just explaining you the syntax itself. So this call returns an object of this class, and when that object calls the name method, it returns the name of the class as a string. That's why we need the string. Okay, and if I show you the corresponding output, corresponding output here, the first line outputs class Y, that is star XP, the type ID of star XP, and the second line outputs a class X pointer. That's what is returned by that name method, and we threw it on the screen. That is, the only purpose of those two lines is to show you how type ID works. Okay, just to give you an example. Now comes the solution part. Okay, so I want to call the getC method. I cannot call it directly using the XP pointer because it's a base class pointer. So what do I do? The solution is similar in both the techniques. It is in type ID, we check the type of the object. Okay, and confirm that and declare a pointer of that kind of class and call the method. So what are we doing? We are saying if type ID, remember this had returned class Y, right? And we are typecasting it to be a string because that is how I know how to compare it. So if class Y as a string is equal to class Y, right? That means when will this return class Y? Only if it is pointing to a Y object. If it was pointing to an X object, then this if statement will be false and we will skip this code. But if at this point it is pointing to a Y object, then this the if condition will be true. That means it is pointing to a y object. So it is safe to create a y pointer and make it point to the same place as xp can point to. You cannot do this. It is not safe to do this just like that. It is, I cannot do all the time yp is equal to y pointer xp. It is only safe if xp was pointing to a y, an object of type y. Okay, so therefore I have checked first. If yes, xp holds the address of a y type of object, then create a y pointer yp, make it point to the same place as the base pointer was pointing to. So at this point in time, how many pointers are pointing to y1? After this statement? 2. xp is also pointing to y1 and yp is also pointing to y1. And then use yp to call set c. Because yp can call set c. yp is y pointer.
You can use XP as
No.
because XP is also pointing to.
That's the, if I could use xp then there was no problem. Why can I not use xp? Because the method is not virtual and the method was not introduced in the base class. So that is why.
But prior to that, XP is also okay.
xp is pointing to y1. You are right, but xp cannot call set c. Okay? So that is why we are creating yp, making it point to the same place that xp was pointing to, and then using yp to call the set c. That sets it to c to be 5, and then using it to get c, and basically if that is not true, then outputting not pointing to a class y object, and that is why when this code is run, you get 5, because it was pointing to a y class object. 5 is first set as the value of c, and then get c throws the value on the screen. Okay? So what I would suggest is copy and paste this code and run it, make changes that you want to change, play with the type ID operator and just get a feel of it. Okay? I don't require you to use this in the project. The project will depend on how you have implemented it, and that is why this has a very high likelihood of showing up on test 2. Okay? So in a way you have kind of a question right here for test 2. So make sure you understand how RTTI works. Another way to do the same thing. So we are not doing anything new. Those are the settings for 2005. I need to update that. Another way, so this is an option, right? So you can achieve the same thing using type ID operator. Another way is to do dynamic casting. Dynamic casting takes a different approach. Remember the type ID operator is like the cautious approach. Some of us like to be cautious. We want to check everything and then see if I want to try it or not, right? So some others of us are more enterprising. We say, okay, let's first jump, then we'll worry about it. It's like my 2 kids. My daughter will make sure everything is safe before she tries something. My son will first throw himself in the situation and then worry about, if needed, make enough, ruckus and creep. Yeah, so that's exactly what here it is. So in dynamic casting, we say, okay, we know everything about this whole wide world. I'm going to create a YP pointer and make it point to X. If it works, very good. I can call the set C and get C methods. If it doesn't work, then I'm sorry. So that's the point of type. Type ID, first check the type and then created the pointer. Here it will first create the pointer and make it point to the same place as XP and then see if it worked or not worked. Okay, so it's just 2 different ways of doing it. So same, nothing has changed in class X, nothing has changed in class Y. Main method. same thing, created a y object, a base class pointer, made the base class pointer point to the derived class object. Right? So till here it's the same. Now we said, right, we know everything, we don't need to check. We created a y pointer yp. We made it point to the same place as xp. The only thing different is, last time I had a y pointer in bracket in front of it after checking that it is a y class object. This time I am not checking, I am just making it point to the same place as xp, but what I am using now is called a dynamic cast to y pointer. What does this do is, the dynamic cast will check what is the type of the object that xp is pointing to. If it is class y, okay, only then will it let yp point to that object. Otherwise, it will set yp to null. Okay? So, dynamic cast does the needful. It says, so yp is saying, okay, I'm ready to point to the same object as xp is pointing to. Dynamic cast says, wait, let me check your credentials. Should you be allowed to point or not? And then here we check yp. If yp is null, this condition is false. So here we are checking if this was ever successful or not. Okay? If it was successful, then we do the same thing. If it was successful, I call the set C and the get C the same two codes which leads to 5. If it was not successful, I am saying it is not pointing to a class Y object. That's the only difference. So whichever you like better is the one you can use. Okay? So at least know one of them. So I wouldn't ask you specifically use type ID or dynamic casting, but I will give you a question in some form where you will have to use one of them. Whichever one you want. Questions on this one?
What is the syntax for dynamic casting?
Syntax for dynamic casting is exactly what you are seeing here.
Does it take only the pointer type or?
Show you one second. So dynamic cast, in the angular brackets, you are putting the type of pointer you want to cast to.
It's not just type, it's type of pointer.
The casting is the important part, dynamic casting. If you don't put the term dynamic cast, typically it automatically. So this code here, the type ID, the default is static cast. Okay? And when you use dynamic cast, then you have to specify dynamic cast, and this comes in an angular bracket.
I mean, instead of white star, can I put white?
Is it a Y star? No.
It only takes the pointer.
Yeah. Okay. And on that note, I kind of skipped it, and I don't need you to worry about it. But those of us who want to be sure about everything you read, in chapter 2, I believe they talk about casting. and they talk about 4 kinds of casting. So there is one that is static cast, which is default when we convert doubles into integers, integer into double, any kind of casting, character into integer, that by default is static casting. You see dynamic casting is very special, it is used for runtime type identification. Okay, and then there is something called a reinterpret cast, and I don't remember the 4th term, but you will typically not find yourself using them. Reinterpret cast is specifically used for when you are doing some systems level programming. So, see, pointer stores an address, right? So if you think of it, a character pointer is no different than an integer pointer or an x pointer or a y pointer. They all store memory addresses. Why do we need that extra point of information, whether it's an int pointer or a character pointer or a x pointer, is to know how much to read and how to read, right? That's the reason we need that. So essentially, when we are dealing with pointers, it is okay to say any pointer and assign it the value of any other pointer, because they both store variables. So when you do systems level programming, as long as the programmer knows what he or she is doing with the pointer, it's okay if the pointer points to 2 different data types at 2 different times. As long as the programmer knows why he or she is doing that. You know, I'm just making it up, but just to make it more understandable at this level, let's say for whatever weird reason, I needed to only read the first byte of the integer. Integer typically needs 4 bytes of storage. But for whatever weird reason, I'm putting some algorithm together, I'm doing some application where I want to do some encryption for whatever weird reason, I just want to read the first byte of the integer. One way to do it is to have a character pointer point to an integer and read it. Because what does the character pointer do? Uses the address to read 1 byte of memory. But you have to know, right? So then they have this reinterpret pointer, where it lets you change the type of the pointer. But for you to use it, I mean, generally we typically don't end up using it, but there are 4 types of castings that C++ supports. You were checking, did you check the 4th one?
I think it was not in the second one, I think it was the 3rd chapter. I did read it.
Okay, the 3rd. But so there are those 4, but static is the default that you use, the dynamic is the other one I need you to know. Okay? So that is something not on the makeup test, for sure. Okay, so as I had mentioned earlier, I want to break the ice on to the topic of design patterns. So what we see in these slides is basically there are known as, I don't know if you've heard of it, but the acronym is SOLID, SOLID, and those are the design principles that the object-oriented design principles. So we will take a quick look through those and then introduce ourselves to design patterns. Before I move forward, what is your understanding of design patterns? What are design patterns?
Solution architecture.
Yes, that's a good word to use, solution architecture. To my mind came the term templates, not meaning the the technical term templates that we learned and STL, not that way, but like a blueprint when I say template. So what happened over the years, right? So object-oriented programming has been around since 80s, which is a long time, right? So we are well into the 4th decade of object-oriented programming. There have been problems that have come up, and there have been solutions developed for these problems. And over these years and years of development, we have figured out that the problems are many times similar. They're not exactly the same, but they have the same components. Okay? So over the years, the experts who have been in the field have seen that there are 23 design patterns. Okay, so there have been these 23 groups, if I might use the term, of problems who have been served by this kind of a solution. Okay, so design pattern is not a piece of software, but it is an architecture that is provided to you, which you can use to develop your software. So therefore, if you remember when we did the object-oriented theory part, design pattern we had seen has a problem. We need to know what kind of a problem should I be, if I'm facing, should I use that design pattern? What kind of problem is it trying to solve or proposing the solution to? What kind of components do I need to create? In our software world, these typically translate to classes. Okay? And then what does the solution look like? And then also an evaluation in terms of what are the strengths of these solutions and what are the limitations. The example we had seen in the OOP theory slides was the server, the client server, right? So one of the limitations is, one of the strengths is it can handle multiple connections at the same time. But the problem is also that, or the limitation is that it is loosely coupled. If it goes down, so like a bank transaction will not use a client server. We cannot say, okay, you say I deposited my hard-earned money, now the bank says, oh, the server went down before you did that. Then there has to be a rollback mechanism that it only gets committed after this is done. So there are different kind of architectures for that way. Okay. So again, as we start walking this road, know that design patterns are like a blueprint. Okay. So let's first start with object-oriented design principles, and here is the acronym I was talking about. So SOLID, S-O-L-I-D. A little bit about characteristics of bad design. When do you call a solution is not great? I mean, it's bad design. Number one, rigidity. That's why when we said, if in our project we can keep things flexible, right? If I ask you what would you have to do if I made this change and you said, oh wait, I need to change my code here, then your code was rigid. You had to change it to accommodate change. That is rigidity. Another thing is fragility. It breaks. Oh, I cannot handle it at all. I never thought of that. Right? Even if you didn't think of it then, can it accommodate it in a way? Okay? So that's fragility. Immobility, that was big. Can I bring it. You did a great job of doing this. Let's say you did a great job of creating a dice. Then if tomorrow you have to do another application which uses a dice, you should be able to take it as it is there. Can you do that or not? That is mobility or portability, and if you can do it, then it becomes immobility. Okay? So those are some things that are characteristics of bad design. So to help us not fall into that trap, experts came up with these design principles, which the acronym is SOLID, S standing from single responsibility principle. So every component should have one responsibility. That's it. So the dice class job is to create a dice. That's it. So you don't say, okay, dice class object is to create a dice and to create the mouse and to create this, right? Then that is where problems occur. So therefore, one thing to remember is single responsibility principle. The idea of the O stands for open-close principle. We'll look at it same way, Liskop's substitution principle, interface segregation principle, and the dependency inversion principle. So let's look at them one at a time. Single responsibility principle, again, pretty much like you know how those Swiss Army knives are. A lot of functionality in the same little compact thing. We don't want to do that here. If you are designing a screwdriver, then let it be a screwdriver. If you are designing it to be a small knife, let it be a knife. Don't put everything together in one class. So what it says is just because you can doesn't mean you should. Okay? That's the simple thing. So a class should have only one reason to change. Open-close principle. Okay, is very interesting. Software entities like classes, modules, and functions should be open for extension. Remember, hierarchy should be extensible, but it should be closed for modification. Okay, so if I'm putting, so the thing that here it says is if you have to put on the coat, because you're going to put on the coat on your chest doesn't mean that you have to open your chest for an open heart surgery because you were putting on a coat. So you can extend, you can put on more layers, right? But you don't need to. But it is closed for change, but open for extension. That is the point of the open-close principle. The next one says substitution principle. Derived types must be completely substitutable for their base types. Okay, so that just is another way of saying that the child class is still an object of a child class, still qualifies to be an object of the base class. As you are extending, so in other words, you shouldn't derive from a base class and put all its methods in the private section. Remember we saw the using thing to put one or two things. So don't put everything in there and create a new thing. So that's what it's saying. If your derived class was a real duck, then your child class shouldn't make it into a dummy duck. Okay? So you are specializing, you are adding more functionality, you are making a special duck, but you are not changing it. If it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction. That's what it is saying basically. But that's the point. Interface segregation principle, the eye of the solid. Client should not be forced to depend upon interfaces that they don't use. So you want me to plug this in, but where should I plug in? Kind of, right? So what we are saying is that the interface, and this is very nicely handled by one of the design patterns that we will be looking at. It is called a adapter design pattern. So, same thing, like, if you have, what is here is an HDMI cable, right? But what you have does not have a HDMI slot. What do? You have all these adapter cables, right, that adapt one thing to the other. So you get one of the adapter cables and you put it in. One of the adapter cables I'm right now using for the VGA. So my machine here does not have a VGA slot. So what do? I get an adapter cable that lets me cross the bridge, right? Make the connection. So that's what we are looking at here. And then finally, dependency inversion principle. Would you solder a lamp directly to the electrical wiring in a wall? You would not, right? So you would use the plug. High-level modules should not depend on low-level modules. Both should depend on abstractions, and abstractions themselves should not depend on details. The details should depend on abstractions. So the way you go about it. Okay, again I'll put them in here so that somebody has thrown this terminology at you. So tomorrow when you hear the acronym SOLID, even if you don't remember, because we are not going to use it, I'm not going to ask questions on it. So on that note, you can forget about it. But I think because it is something that is frequently used out there in the world, in your job market, it would be something that you have heard about and you would have a starting point if you ever needed to learn more about it. Okay, but from our point of view, it is there because it made sense to be here, and I wanted you to, again, break the ice on this one, but I wouldn't ask you questions. Here, this is where we formally start off with design patterns. This is the book written by the people. They are 4 people who have put this together, the book, and it's pretty much the Bible in this context. So, in the syllabi, I had put it as a reference text. If you were to go into this field, and this is a very good book to have. But again, if you are not treading this way, then you don't need it. Okay? But this is where the 23 design patterns are described in detail and looked into. Another good one is Thinking in Patterns with C++ by Bruce Eckel, and there is another, and these are the 3 sources that I use to make these slides. Okay, so that basically gives you the sources. So someone very nicely made a periodic table of the design pattern. Remember seeing that in chemistry class in high school, probably for the elements. So this is the periodic table for the design pattern. Okay, so if you see, these design patterns are colored using 3 colors. All of those who are in yellow are your, what are they called, the creational design patterns. Okay, these are used at time of object creation. If you need something special, you fall back. So if you are thinking of your software and at the time of creation you need some stuff, you are saying, oh, how do I solve this problem? You look for and you say, have others found this problem? If they have, probably chances are you'll find a solution in the design patterns. The green ones are behavioral design patterns, and the blue ones are the structural design patterns. They are 23 in number. We will be looking at 7, some of each one of them. Actually, the simplest of all 3 is what we are going to look at here. So again, design pattern, to give a definition, identifies a popular design strategy and documents the domain-independent leverage. Adapter, use an extra level of interaction to make 2 incompatible objects compatible. Okay, so adapter is one of the design patterns right up there. The one that says 139 adapter, okay, is one of the structural design patterns. A common problem we face is that I have a connector for a 2-prong plug, but I have a 3-prong plug. How do I use it? a cord with a 2-prong outlet, and I have a 3-prong plug. You go to Home Depot or Lowe's and buy this, the adapter. That converts the 2 into the 3. That's exactly what the adapter design pattern does. If the client is calling a method, used to call a method using 3 parameters, you are saying, I have developed this software, does an excellent job, much better than what you have been using till now. Let's say, to keep it simple, to add 2 numbers. But you know what? I designed the function that took 2 parameters. Now if you tell the client that you change your code, that will not sit well. Because that code could be, thousands of pieces long, lot of other software depending on it. So what is a good thing? Create a class that does what? Something like so you create a class that where the add method can be called with 3 parameters that the client was doing, and that method calls your method passing the 2 that should be passed, or if the 3 have to be manipulated in some way to create the 2, that is what it does and calls your method. So you created an adapter. The client doesn't need to change, you don't need to change. Everybody's happy. Okay? So that's an adapter design pattern, basically. A little bit about design patterns. Design patterns represent solutions to commonly occurring problems that arise when developing software within a particular context. A pattern does not give the detailed code, so as I said, it's not a piece of software that you use as it is, but it gives the general form of the solution. You will need to declare a class to do this, a class to do this. When we see design patterns, we'll see code, but know that it has to be adapted and changed to the context you are working at. The user of the pattern must adapt the pattern to the particular case at hand and supply the missing details not given in the pattern. And patterns help you learn from others' successes instead of your own failures. So you don't have to fail before you say, I'm going to use it. You see, what have others done? Have they had same kind of problems? So that's the point that has been made there. Why use design patterns, right? It's a good time to step back and think before we put in all the effort and energy into learning design patterns. Why should we learn about design patterns? Number one, it gives a common language between all the developers that are working together. Now, design patterns are language independent. You might use them when you are doing C++, or you might use them when you are using Java or C#. They are not language dependent. So you don't have one set of design patterns for C++ and another set of design patterns for Java. Design patterns are, a solution to issues, and then how you implement those solutions depends on the language you are working with. It speeds up your development. It provides some pre-existing documentation, and it's a way to refine your solutions. So 4 major reasons to use design patterns. Again, I think the most important of those probably is the second one. That instead of sitting and reinventing the wheel, you seek and see what others have done. So here is one more time, it's a kind of a revision of parts of a design pattern. Every design pattern will have a name. When we saw adapter, that was a name. It conveys briefly and succinctly the subject matter of the pattern. It increases our design vocabulary. We should know the problem, where this design pattern is to be used. So where was adapter used? If the client and the class, I will use the term, did not have the same interface kind of a thing. So it identifies the condition under which the pattern is applicable and what is the solution, like we were discussing. Declares this new class which has the prototype of the client and makes a call to the class that already existed. So that's the solution, specifies the elements that comprises the solution. In my example, there was one class. Some design patterns will have a one class structure, some will have a multiple class structure, depends on the design pattern. Their individual responsibilities and the manner in which they collaborate to achieve the solution, and then the consequences. What are the strengths? What are the limitations? Both are very important to know. Okay, so what are the positive and negative consequences of using this pattern? Types of design patterns, they are divided two ways. Okay, just like we said, inheritance can be divided two ways. If we look at number of parents, we can say whether it is single or multiple, and if we look at the filter that is used, then it can be public, private or protected. Same way design, in a similar way, the design patterns can be divided on basis of purpose. Then they are divided into those three that we said: creational, structural or behavioral. Or they can also be divided depending on scope. So some of the design patterns are related to primarily to classes, and they are said to have a class scope, and some of them have an object scope. Okay, so those are the two ways we divide the design patterns. And this last slide basically shows you those 23 listed out. Okay, so those are the on the top as columns. You see division by the purpose, which was creational, structural, and behavior, and on the row wise you see it according to scope. So class scope and object scope. So if you pick up any design pattern, for example, again I'm going back to adapter because we talked a little bit about it. So adapter is a structural design pattern with class scope. And the ones where you see the red checks are the ones we are going to do. So you will see that we will look at factory method and singleton. Both are creational. One has class scope, the other has object scope. We'll see a lot of the structural design patterns. Adapter can be both places. You have bridge, decorator, and facade. And then we'll see one behavioral design pattern, which is the state design pattern. So that those are the 7 design patterns that we would be looking at. Okay. So so Monday we will use the class for the part 3 and 4 of the project. But the Monday when we come back after Thanksgiving, we will look at we'll do the creational design patterns, which are the factory method and the singleton. I have made available all the PowerPoint slides, so anybody, if you want to start looking ahead, you can. If you want to wait before we cover it, that is also fine. I don't recommend one way or the other. I don't want you to look at it and be overwhelmed. If that is what you expect to happen, stop right there and then. But if you are curious, you want to look, absolutely, it is a good thing to do. One of the most simple ones is the singleton, and that's why we'll cover it on Monday, and I will encourage you to use it in your project. And I'll tell you exactly where you can use it. It's pretty simple. Okay? So I'll stop there, and we'll see each other Monday. Right?
Yes,